Hi, this is Ben Welsh coming to you from the LA Times newsroom. And in this video, I'm going to show you how to import data into your Jupyter notebook using Python's Pandas library. All right. Now, you may remember where we left off is we had a terminal open where we had checked into a virtual environment that had all of the Python tools like pip and the Jupyter notebook and all that stuff installed. Now, if all the jargon I've just spit out doesn't make sense to you, that's probably because you've missed the earlier chapters of this lesson and you need to go back and check out the earlier videos. If you know what I'm talking about and you can get your terminal up and check into your virtual environment to activate it and get your Jupyter notebook running, then you're in the right place. All right, now if you already have your notebook running, don't worry, but just as a reminder, to get it started again, you type in Jupyter with a Y space notebook. And that's going to open up our Jupyter notebook for us to begin work. And in the next few minutes, I'm going to show you how to use Pandas to read in a data file and to begin working around with it and exploring it in Python. The data files we'll be working with come from the California Civic Data Coalition, and I'll show you how to get them in a minute. But first, we need to make a new notebook to start off. All right, so as you may remember, in the upper right-hand corner, there's a new pull-down that appears right here. You're going to click on that and then go to Python 2, which will create a blank new Jupyter notebook. Now, because we're going to use Pandas to read in our data file, the first thing we need to do is import it here so it's available. Again, we do that by typing Python's built-in import command, and then the word Pandas, because that's the name of the library, and then finally the common alias PD, so that we have a sort of shortcut to which we can refer to Pandas without having to type it all out. Import space Pandas space as, which tells Python we're going to declare an alias, and then a space, and then the alias itself, which is PD. And in our previous lessons, you may remember we were able to do pd.this and pd.that to create a data series and begin working with it, right? Now I'm going to teach you another trick inside of PD that allows you to read in data that's stored in what's called the CSV format, or comma-separated values. And what that really is just a fancy computer programming way of saying a spreadsheet or a file that you could open in Microsoft Excel. And it's just columns or tables of data that's stored with commas between each of the columns so that the computer knows where to split the file and how to structure things. Now, back in our lesson at firstpythonnotebook.org, in the chapter we're now working through, there's a table at the top where I've provided the link to two different files. And we can use the URLs for these files to have Pandas read in the data and take a look at it. But before we do that, I just want to show you what's going to happen. So I've already downloaded this first file, committees.csv, which is a list of all the campaign committees active in the 2016 ballot measure races here in California. And I've already opened that up in Microsoft Excel. And so that CSV file is nothing fancy. It's nothing you probably haven't seen before. It's a data file prepared by the California Civic Data Coalition for us to analyze that has a row for every ballot measure committee and the proposition that it was linked to in 2016, right? And so there's every column here has a title. There's an identifier for the propositions from 2 or 3 different database systems that the California Civic Data Coalition has collated for us. Then there's the name of the proposition, Proposition 51, 52, 53. This is the name of the propositions as they appeared on the ballot. And then the committee that was active on each of those. And there's one row for every committee and its connections to a proposition. So we can see here that yes on Prop 57 was active on Prop 51, or yes on Prop 51, pardon me, and so on down the line. And then here in a final column, it's listed whether that committee supported or opposed the measure. So yes on Prop 51, which is listed as support, unsurprisingly supported Proposition 51, and so on and so forth down the list. Now, here in Microsoft Excel, you could probably do some pretty good data analysis on this file if you knew what you were doing. If you knew how to sort and filter and create a pivot table and kind of mess around with this file, there's probably quite a lot you could get done. And a lot of great data journalism does happen in Microsoft Excel. It's great software. But some downsides are once the file gets to a certain length, say millions and millions of records, it becomes difficult to work with. Another is if your analysis has many different steps that need to be executed in a certain order for things to happen, say 10, 15, 20 clicks to sort of get to the bottom of what you're trying to do. If you do it once, it can be pretty tedious to repeat yourself, and you might not remember everything you did. And those are two problems. There's a couple more other problems, but those are two big problems that working with Python and computer programming can help you solve. You can work with bigger files, and everything you do is going to be really clearly documented in this Jupyter notebook. But you don't have to take my word for it. You're going to see you're going to see it. You're going to see why in the next few minutes and over the next few lessons as we continue to walk through this. All right. So let's get it out of the spreadsheet and into our programming code. So that's going to be our next step. So I'm going to go back to the tab here on the lesson plan, and I'm just going to right-click on the hyperlink for that download, and I'm going to go to Copy Link Address. So now my clipboard has the complete URL that goes to that file. All right, so I'm going to store that away for a moment. Now I'm going to go back to my notebook, where all I've done is import pandas. And now pandas just happens to have a very helpful method called read CSV, which allows it to take a CSV data file and read it into pandas so that it can begin to work with it. And the way you get to that is you type PD, which again is our alias for pandas, period. And now, as you may remember from the previous lessons, there's all sorts of helpful commands that are hidden behind that period. The dozens and dozens of tools built into the system ready for you to access, whether you know about them or not. And again, you can hit the tab button in the notebook just to get a sneak peek at what those many methods are. And hey, there's the one we're going to use, read underscore CSV. So by typing read underscore CSV, I'm accessing that method that's deep down inside of pandas waiting for me to take advantage of it. And since it's the one I want, now's the time. Then it needs to know which CSV it's supposed to read, right? So this method expects an input. It expects us to give it some information about what it needs to read in. Now this method could read in files off your computer if you gave it a path to a folder on your system, but even better, it can read files directly off the internet. And so we're going to give it the URL that I copied to the clipboard as an input to tell it to go to that link and download the file and read it into this system. And to do that, you have to open a parenthesis, and the notebook will probably automatically close a parenthesis right after it. And that's because this is the typical way in which a method accepts inputs. So in Python, when you have a method that needs an input, usually it's a pair of parentheses that are opened and closed immediately after the name of the method, and then inside that parenthesis you put the 1, 2, 3, 5, 10, 20, however many inputs are necessary for that function to run. In this case, there's really only one input it needs. It needs either the path to the file on your computer or the URL on the internet where the file can be downloaded. I'm going to give it the URL. Now, it expects it to be put between two quotation marks so that it knows in computer speak that this is a string of characters that it's going to interpret. So I'm going to put two quotation marks right there. You can see them separated. And then between them, I'm going to paste in. Oh, the paste didn't work. I'm going to paste in that URL. Let's try again. Copy the link address. Paste it in. There. Now, if you're typing it from scratch, you got to get it exactly right, which is why I pasted it. But just so that you can see it, I'm going to leave it here for a second and I'm going to read it out. It's a standard web address. It begins with http:// then www.firstpythonnotebook.org/static/committees.csv. I've typed all that in, and again, just like anything else in the notebook, I can go to the top and hit the play button. That will now run that cell, and what you can see is that immediately below it, it should have printed out a table, not unlike a spreadsheet, that reflects the structure within that file that's been detected by the computer. That this is a list of rows and columns that can be broken up into a grid. It's not quite as pretty as Microsoft Excel, but in some ways it's similar. You can see those same columns that we saw in Excel are bolded here at the top, and below them are the data values that are found in each of the rows as you scroll down. You should see something very similar. All right. Now this output And the thing that is sort of created within Pandas when it reads in a CSV file is what is known as a data frame. And this is a term that you're going to hear a lot if you read about Pandas elsewhere on the web and as we work through this course. And the data frame is just a piece of jargon that was invented in Pandas to describe the table of data or the spreadsheet of data after it's been read into Pandas and when Pandas is sort of using its many methods to operate on it. So that it's kind of a strange term. It's often spelled capital D, capital F. Data frame is one word. But all it really means is a table of data that you've read in from a CSV or a database or some other source, JSON data perhaps, into Pandas, and then it's going to interpret and interact with in the same way Excel would interact with a spreadsheet. All right, but as you can see, all we've done so far is just print out that data frame. We've executed our line of code, and all it does is print it out. And it's only printed out the first few rows because that's kind of the way these things work. But there's not much else we can do with it at this point. It's just there. It's been printed out. We can't access it in future cells. We can't use other methods to mess around with it unless we figure out a way to save it for later. All right. And here we're going to introduce one of the fundamental concepts of computer programming that some of you may know and some of you may not, and it's totally okay if you don't. And it's what's called a variable. And a variable is really just a shortcut where you can save values and operations from your scripts to use them later. And it's sometimes called a namespace, which is again a very technical term, just like variable, but it's really just a shortcut that you choose the name of that you can reuse later on in your code. And so what we want to do at this stage is we want to save our data frame into a shortcut so that we can reuse it in subsequent cells as we work down the notebook so that I can teach you some other cool things we can do with a data frame. All right, and the way we do that is we're going to go back to this cell that we just wrote. I'm going to click on the far left-hand side before all of the code, and now I'm going to type in the name for this data frame. And like everything in programming, naming things is hard. There's rarely the perfect name for anything. You just come up with the best thing you can, and usually short is good, but not too short so that it's confusing. Since this is a list of propositions and their committees, I'm simply just going to call it props, okay? And so I'm going to do props as the name I'd like to give this, a space, the equal sign, and then another space. And this is now, when I run this code, going to save the result of this Pandas code into this variable so it can be reused later. So now I'm going to go click on it and hit the play button again. And now you can see it's run, but nothing is printed out. The data frame that was dumped into the notebook before has disappeared, and we've simply just moved on to another cell. And that's because the output of this method has now been saved into here rather than printed out into the notebook. Now, printing it out again is not hard. I can go to this next cell, and I can just type that shortcut, props, and I can hit play again. And you can see there it is, exactly as before, in fact, identical to before, is the output, right? But we're able to print it out when we choose rather than having it just go out. And here's the fun part. Now that we've saved it, there's all sorts of other cool stuff we can do with it, right? We can do another magic period like we did before to allow us to access a whole different set of magic methods that are available on every single data frame. And there's two more I'm going to teach you in this video that I think you'll find really useful and that I use almost every single time I read a CSV file into Pandas. All right. The first is called head. And all head does, you just type it props.head, open parenthesis, close parenthesis. This will call the head method, execute the head method on the props variable. All it does is print out the first 5 rows of your output, of your data frame. They're output right here into the notebook, and you can inspect them. You can look carefully at what's in and all the columns and cells and sort of peek in and get kind of a clue of what the data set you have read in looks like. And this is a very handy command that I use almost every single day, and that if you get into this process, you probably will too. And by default, it prints the first 5. But if I wanted to say just print the first 1, why, that just happens to be the input for head. So if I were to go back up and put the number 1 between the 2 parentheses and hit play again, now head will only print out the first row. If I were to put in 7, it would print out the first 7. But again, the default is 5, and you don't have to do anything other than that, right? But again, just to make the point, the way that Python methods work is that they are executed with the open and closed parenthesis, and then they accept an input that will tell them what to do, right? Some don't require any input and have defaults that allow them to do something sensible, like head. Others have required inputs, like read CSV, which is unable to run unless it knows what CSV file to open. No one was born knowing what all these inputs are, and they can vary quite a bit and are sometimes not what you might expect or even like them to be. But they are what they are because they're Python code deep down inside pandas that the community of pandas developers have sort of landed on. And these methods are all documented on the internet, and if you're ever using a new method or have forgotten how to use one that you've used in the past, I would recommend you just Google the name of the method and pandas, and you'll find a documentation page or examples of other people's code where those inputs are spelled out really precisely. Okay, now I'm going to scroll down beneath this cell to where a new one has been created, and I'm going to show you another really helpful method that I use all the time. This one is called info. So again, I'm going to type the name of my variable, props, a period, and then the word info, which is short for information, right? Info, open parenthesis, close parenthesis. Again, I'm going to hit the play button. Props, period, info, open parenthesis, close parenthesis, play. No spaces in there, everything just stacked together. Now it's printed out something else. This is something we haven't seen before. This is a short informational report about the makeup of this table. And it's giving us some perhaps difficult to read, but very important information that you probably want to know about almost any table or data frame that you read into pandas. First off, it's telling us this data frame, and you can see it's defined as a data frame there, has 102 entries. That's telling me there's 102 rows in this data frame. And if I were to go back to my spreadsheet and scroll down to the bottom, I can confirm that's right. This says 103, but that's because there's a header row in Excel that Excel is counting. So once you skip the header, there's 102 rows of data in the spreadsheet, and 102 entries have been logged here in Pandas on the way in. And as you have more or less entries, this number will change every time you run info. This is a nice quick way to get the count of rows in your data frame. It then goes on to tell us that there's 8 different columns in the data frame, and then to list them one at a time by their names. And we can see that these column names correspond exactly to the column names we saw when we ran head above. But it doesn't just tell us all the column names. It also tells us, though in a little bit of Pythonese, the data type, what type of information is stored in each of these columns. And you can see there's 2 different things that we see here. There's some that are called object, and there's other that are called int64. Object is Panda's way of telling you this column is a character field. It has the letters A through Z and all sorts of uppercase and lowercase letters as part of what's in it. int64 is telling us this column is an integer column, which means that it has numbers with no decimal places. And it's going to be able to do different things with all the Pandas logic depending on what data type these columns are. If your column is an integer column or a float column, which is what decimals are called in this world, you'll be able to do all sorts of mathematical operations right outside of the box using those columns. If it's not, if it's a character column, you won't be able to do some of those same statistical methods, but you will be able to do a whole other set of string manipulations to sort of search through the column for different character patterns, replace or otherwise manipulate the letters to do whatever you might need to do as part of your analysis or data work. Finally, it gives us a little more information about the size of the file and the data. Oh, and I forgot, here in the columns, we also get some information on whether there are any null values in any of these columns, which is, again, just a fancy computer way of describing whether there are empty cells in the spreadsheet. And you can see here that all of these columns are completely filled with data because they've all been marked as non-null, right? And 102 rows here overall in the data frame corresponds to the number of columns within this data frame where the rows are filled. So there are 102 rows, and for all columns there are 102 values. So this is a completely filled spreadsheet, is what that's telling me in this case. If there was a column that had lots of empty values, you could really quickly see this here, which can be very helpful when you're trying to quickly analyze a database or other file. All right, so those are the basic things I wanted to show you, and we're going to do one more exercise to kind of review them before we finish this video. All right, again, there were 3 steps that we learned. After importing pandas, we learned how to read in a CSV and save it as a variable. We then learned how to use the head command to take a peek at the first few rows. And then finally, we learned how to use the info command to get some diagnostics or a report card on everything that's inside that file. So we're going to repeat those 3 steps, but we're going to do it for a different file. There's a second file back here linked at the table, which is called contributions rather than committees. I'm going to copy the link to that one, and we're going to do these 3 steps for this second file. Now this file, rather than being a list of all the committees active on all the propositions, it's instead a list of all the campaign donors, all the contributors who gave money to those committees. So it's a lot longer list, and it includes a lot maybe more interesting information like the names, employers, and occupations of campaign donors. So to begin, we're going to name our variable that we're going to save this data frame into. I'm going to call it contribs, which is just shorthand for contributions. So it's a little shorter to type, and I can save myself some time and space. Contribs space equals, and again, I didn't have to call it contribs. I really could call it anything. That's the way variables work. So I'm going to say contribs space equals. Now again, I need to return to pandas itself to access its built-in read CSV tool to get what I want. So it's going to be PD period read underscore CSV, because that's the name of the method, parenthesis, and then inside 2 quotation marks, I'm going to paste. Now again, I lost my paste. I'm going to go back in and try again. And I'm going to paste in, there we go, paste in the URL to that contributions. And again, it's http:// everything is the same up until the very end, where instead of committees, it's now contributions.csv, closing the quotation, and then closing the parenthesis. So that will then use read CSV to read this file from the internet into the variable contribs. Once you're ready, do as I'm doing and hit the play button. This may take a minute, as the file will need to be downloaded off the internet and saved in here. Again, you could read this off your file system if you were to download it in your browser, put it on a location in your computer, and then put that path into Pandas. It would just as well read the file. But in this case, I think it's easier and a little more fun to read it right off the internet. So I know it's completed because the asterisk here has been replaced by a number, and I can go down to my next cell and I can begin working with my contribs variable. Contribs.head, open parenthesis, close parenthesis, and then play. We'll run the head command on this table. And we can see that here in the first row was a contribution made in September 2016 to a committee called Adult Use Campaign for Proposition 64, which, if I remember correct, is a proposition about whether pornography actors should be required to wear condoms. Welcome to California. It did not pass. You may see something different depending on the file and the state of it at the time of the download, as this will evolve over time. But usually you will see something like this where there'll be a row per contribution with a committee, a date, and now we're beginning to see peeking out on the right-hand side some information about the identity of the donor, which you can see by sort of scrolling down and pulling over your data frame preview. You can see that Gretchen Bergman of Spring Valley, California, who lives at this zip code, right? How much did this person give will then be available as we scroll over. And we can see that this person, who was the executive director of a company called A New Path, I'm going to keep scrolling. This person made a campaign contribution of $84 to that committee. And that's what's been recorded here. And this goes on and on through the file as you proceed down. How many contributions do we have, you might ask? Well, we could go down to the next row and we could type in contribs.info open parenthesis, close parenthesis, just as we did before, and hit the play button. And now we'll see that again, all the different columns have been printed out from above, including a lot of different numbers about how many records are there and how many are empty, the data types of the different columns. We can see it that this table now has a float field, which we never had before, which again is a decimal value because of the dollars and cents in that amount column, and a bool column, which is short for boolean, which means a value of either true or false. How did Panda know all this? It just guessed it based on the content of the data file, which is one of many very wonderful features built into Pandas, which is without you having to tell it what type of data is in each individual column, it sort of just figured it out and did it for you. Now again, your numbers here might be slightly different depending on the file at the time that you watch this video, but you should see something along these lines. Now, that's all I have to teach you in this particular section, so I'm going to go ahead and save my notebook at the top, just so it's saved in the system, which is always a good idea to do, and I'll see you in the next one.